Welcome to the last day of EclipseCon. Welcome to my talk about Eclipse Che. My name is Jonas. I'm working for Eclipse Source in Munich. I also want to introduce Matthias, who did most of the development work on this evaluation project, and he will also assist me with the demonstration. The background of this talk is you might have seen quite a few talks about Eclipse Che this week, or maybe also on EclipseCon North America. We were on EclipseCon North America this year in March, where Eclipse Che was published and released first, and we looked at the demonstration, we looked at the technology. It was an Eclipse project, and we as Eclipse Source, we love to learn new technologies, to have a look at them, to use them, and to build up some knowledge about those technologies. So that's what we did. We had a look at the framework. We tried to build our own extension. Our main goal was to gather some experience rather than really building something completely usable, but we have chosen a use case that we are interested in ourselves, that's support for EMF. And what I want to do today in my talk is I want to give you an overview on how you can extend Che in combination with our experience when doing so. So I will highlight some pitfalls, some good things, some bad things. So this is really a third-party view on the framework. So if you plan to extend Che, hopefully this talk is helpful for you. Let me start with a brief overview about Che. So I will not go too much into detail about the framework, but it's important to understand its basic concepts. So Che is basically two things. First, and that's the simple one, it's a cloud-based or web-based IDE that you can use. In combination to that, it's also a system to share workspaces. And workspaces contain the source code, the runtime you run that source code on, but also the tools, for example, that you use to compile the source code. And those three things are bundled together in Docker containers, so you can share them with other users. So it makes it very easy to share exactly the same setup of a workspace with another coworker, for example. Che consists mainly of three components. On the left, we have a browser application. This is written in the Google Web Toolkit, GWT, or also I would call it GWT. That's how they call it. That's a standard browser application. It embeds some other components, for example, the Orion editor, and that's what mainly forms the IDE then. Then obviously we have a server. This provides mainly REST services, and the IDE communicates with the server to trigger some features which are executed on the server, for example, to access files or to create workspaces and all this stuff. And finally, we have the workspaces. Over here, those are really Docker containers, so you can put in whatever you want in your workspaces, and there's a server to share those workspaces with other people. Now, when you think about extending Che, you can extend all three components. You can extend the browser application, for example, to add new buttons, new editors, new wizards, whatever is visible to the user. Some extensions are really only done in the IDE. If you want to add a new action, for example, that's pretty simple. You can extend the server to provide new features. Typically, those features are then accessed from within the IDE. So let's say you want to place a button which then generates some code. The button is placed in the IDE on the browser, and then it calls a REST server on the server, which then executes some other logic, for example, to generate code. And finally, you can also extend the workspace, and that mainly means that you can install tools in the workspace. It's important to know that extending the browser and the Che server can only be done at development time. So it's not like Eclipse where every developer can install new plugins during runtime, but you have to know what you want to use at development time, and then you actually assemble the whole thing, and then you can provide it to the user. The workspace is extensible at runtime, so users can install tooling in their workspaces if they want. So the dynamic extension point is actually the workspace, but there's API to extend the browser in the Che server too. And that brings me to the first major difference. If you're used to extend Eclipse and then you start to extend Che, when you extend Che, you basically use APIs, and there's a lot of API to extend it. You create a plugin hosting your extensions, and then you insert this plugin into the main Che build. So you have to check out the Che sources, and then you assemble the whole thing together, and then you can deploy that on the server, and then users can use that. That has some consequences. Actually, I think one of the main reasons behind that is when you think about a typical Che use case, it's different from the Eclipse use case. Eclipse, we have those standard packages, and then people download it, and then every user starts to install the tools of their choice. And then it's only used by one developer. The goal of Che is actually to have a common setup for a group of people. So let's imagine you have 100 people working on a project. Now the idea is you can extend Che to include all the tools that you want to be used by those people, but then at the end you deploy it once and all people can access the same setup. That's why I would say there's not such a high need to extend it during runtime. So you basically shift the configuration effort to one person who does the assembly, but then it can be used by an arbitrary number of developers and they already have the setup. I would say the second consequence, so I would say from a user point of view, this assembly or the need to build a whole assembly doesn't do any harm. It adds complexity to the build though. So you have to get familiar with the Che build because you always have to build the whole stuff, and building takes a while. So once you get going with that, it's pretty okay, but initially there is some hurdle because you have to build it. So if you're used to Eclipse, you definitely miss Che IDE because there it's really simple to just add a new module and just build your extension, and you can just plug it into a running Eclipse. However, there are plans from the Che team to improve this in the future, so to be able to just compile your plugin and then put it into the main platform. Okay, let's talk about extensions more in detail. When you think about Eclipse, the typical extension mechanism is extension points. Those are very likely not used in Che. So how to extend Che? The main extension mechanism of Che is dependency injection, which is cool because that's a very generic and very flexible mechanism. There are two typical use cases how you use dependency injection. The simple one, not on the slide, is there is a service that you can call to do an extension. So for example, there is a service to register actions that are visible in the IDE. So you can get the service injected and then you just call the API to do your extension. That's pretty simple. The second one, which is a little bit more difficult to understand, but it's very central. If you want to deliver something to the platform, for example, a new project type. So let's envision you wanted to add support for EMF. So we want to define an EMF project, and so the user can create them in the wizard and so on. What you would do is, first there is an interface for project type defined by Che. So that's given, so that's part of the API. Now you implement your own project type, specifying the specifics of your project, and now you have to register this project type at the platform, so the platform knows that you defined a project type. And that's actually done using a standard dependency injection mechanism. Actually, Gin and Juice are used. You probably know Juice. Gin is the browser version of Gin, but it's of Juice, but it's actually almost the same. So you don't have to really worry too much about the difference. So what you do is you create a Gin or Juice module, which actually binds this implementation to the dependency injection context. So now the framework knows that you have an implementation of project type. And it can, for example, show that in the central wizard. We will have a concrete example about that. General comment about this extension mechanism, it's very flexible. You have to learn it once, so you have to understand dependency injection well, but if you understood it once, it's always the same, and it's very flexible. If you compare that to extension points are much less flexible, however, they provide more guidance to the user. So there are a lot of people who hate extension points, but what they really did well is supporting the user in what to do. If you add a new view, for example, to Eclipse, there's a wizard and it tells you exactly what to do. Here, we have to understand dependency injection and we have to know the API to learn how to do. However, it's more flexible. And if you want to extend the server, it's pretty simple. You basically implement the REST service, you register that REST service, and then you can access it. You can access it from within the IDE, but you could also access it from any other application. Okay, so let's talk about the concrete use case that we worked on. So we wanted to have EMF support in Che, and that mainly supports, or that mainly consists of an Ecore editor. So that's the Ecore editor of Eclipse that you might be familiar with. If you're not familiar with EMF, then just imagine we want to support a tree-based editor and load data and save data. So the use case more in detail, we want to be able to create a model project, so that involves project type. We want to be able to create specific files. We want to load and save the Ecore model to the server. We want to have CRUD, meaning we want to be able to create, read, update, and delete the model. And finally, we want to generate code. We have picked this use case because it kind of touches all areas. So it's a pretty small, but I would say very explorative use case. So let's start with the first step. So we want to be able to create a specific project. For that, the first step is to define a project type. If you remember the 2 slides back, the first thing we do is we implement our specific project type. For that, we inherit from an existing class which is given by Che. That's the project type def. And mainly we specify some specifics. So we specify an ID, some parameters. We can add variables. Those variables can then be configured by the user. So if our project type, I don't know, leads a location where the model is or something like that, you can define those variables for project types. And now we have to register this project type at the platform, and that's done in Juice. So what we do is or in Gin, no, this is Juice. So we create a Juice module, and then we create, that's the API of Juice, so that's not really Che specific. We create what we call a binder. We will deliver an object of type project type def, so that's the class we inherit from, and we tell that our implementation is this class, so that's the class from above. And with this registration now, the dependency injection framework knows about our class, and Che will then use this mechanism to retrieve all project types which are there, and then build a list in the create project wizard. There are actually 2 more things to add to that topic before we do a short live demonstration. So I've shown how to define a project type. You can also define a custom wizard if you want the users to enter some specific data related to your project, you can do that. For that, you have to implement some GUID UI, and that can be embedded in the standard wizard then. And the third thing that I would like to mention, we will show that in the IDE, is you might want to add sample projects already containing some example content, and that's very easy to do with Che because you can configure a list of Git repositories, and Che will look at this list, and if it will just show those Git repositories as examples. So the users can directly get the contents of those Git repositories into their workspace. And the nice thing about that is you don't have to deploy your examples, but you can just host them on GitHub. So if you want to update them, you can do that in a central way. So let's have a look at the IDE and the effect of those 3 extensions. So now if we click on New Project, Create Project. So what we see up here, those will be the entries that you get if you define a project type. And there you can enter standard values. Those are available for all project types. If you want to have more values, you would need to define a wizard. And what we see down here, those are the samples. And actually for the demonstration, we have added a sample. We call that make it happen example. We will use it for the demonstration because it already contains a model, so we don't have to create it. And now so this is just hosted on GitHub, and one line to enter it in Che. And then we just click on create. It will get the code from the repository, and then if we open this project, we already have 3 bundles in there containing some content. So that's pretty easy to do. Okay, let's go back to the slides. Next thing that we want to do is we want to register file type. I will not go into detail about how to register the file type because it's pretty much the same as the project type. Maybe interesting, how would it look like if you want a specific action to create your new file type? That's pretty much the same as in Eclipse. There is a ready-to-use action called abstract new resource action given by Che. You can extend from them, and then you just have to specify the extension and the text, or the description, which is shown in the action. So when we go back to the IDE, we can see this action. So you can right-click and new, or like this, yes, new. And now we have a new entry called new Ecore file. And when we click that, we can specify the name. We don't have to specify the extension. And then there's already some content. Matthias, close the editor because we come to that later. If you just register a file type, we can simulate that now by renaming the file to another extension. Yeah, and then open it. The first thing that you get is the standard Orion editor. So this is the default that you get. This is based on Orion. It already supports quite a few languages. So if you have some standard format like XML or something like that, you would already get syntax highlighting. However, now you have to decide which editor to go. And for that, we go back to the slides. And there are mainly 3 possibilities that, at least that we are aware of, on how to implement editors in the middle. So the first one, obvious choice, is to use the Orion editor, because the good news is there are even several ways to extend that. You can extend Orion itself, so that has nothing to do with Che, but if you're familiar with Orion, you could provide new features to that. Che supports the language server protocol. I will not go into detail about that. I think there have been a lot of talks about that. And finally, that's what we did, especially in the beginning a bit. Che also adds additional API on top of the Orion editor. So there's a Che overlay where you can extend the functionality of the standard editor. For example, to add code completion, to add quick fixes, and so on. So there is existing API, and it's pretty easy to do. Okay, so the recommendation is if you want a text-based editor for any language or something like that, the obvious choice would be the Orion editor, because that's already ready to use and it's embedded. It's a quick start. Second possibility, if you want, you could write a custom editor in Git, and then just embed that into the IDE. The Che platform does that for some views, so they are implemented in Git. We did a prototype of that. We didn't want to do it at the end because we are not too much familiar with Git, and also you don't find too many components out there written in Git. So we also wanted to reuse the stuff that we actually write. There is a third possibility, and that's a very interesting one. At the end of the day, Git compiles to JavaScript. So what's running in the browser is a native JavaScript and HTML application, and it's possible to embed your own HTML and JavaScript component into that application. And there's actually a pretty easy way to do that. And this is extremely powerful because you can extend any HTML, JavaScript-based component that you want to embed there. So in other presentations, we have heard about this Monaco editor. So if you want to use that, it should be possible to embed it there. And that opens up a really huge variety of existing components that you can use. That's one advantage. The other advantage is you can develop your components even independently of Che. So let's say you are building up a new editor and you want to embed it in Che, but you also want to provide the same editor on your website for users who do not use Che. That's the way to go, because your component basically stays independent of the IDE. So for our Ecore editor, we were lucky because at the same time, another project of us called JSON Forms actually developed a tree master detail editor for structured data. So it looks like that. We have a tree on the left side and detail pane on the right side. I will not go into detail about that framework. There is another talk today at 1:45, but the basic message is this framework provides us a JavaScript HTML-based editor, which is capable of modifying a JSON tree. So it's not Ecore, but it's JSON. But it's a pretty good start. So we decided to use that one, and our goal was to embed it into Che. So how is that done? I was claiming before it's easy. It is actually, if you know how you do it. Good news is there is documentation now online how to do that. Let's start from the bottom. This Hello World view, this would be a standard Che view, and what it basically does, it creates a panel in grid. That's the standard element, and in the running application there will be then an HTML element representing this panel. This view will just create an empty panel, which is then the placeholder for our editor. Now we have a class that we call Hello World Presenter. This one calls a simple JavaScript file that's actually supported in Grid. So in Grid you implement or you write your stuff in Java, but you can call JavaScript from within there. And now this JavaScript actually modifies this HTML element, the placeholder, and there you can add whatever you want. And what we basically do is for our goal, we actually embed a certain directive in the HTML, which will then produce the complete editor. But you could add anything, so any DOM modification would be possible here. Now, so that's how we embed the editor. Now, finally, you need a way to talk to the editor from the IDE again. So, for example, to tell it which file to open. And for that, we define what we call an overlay. That's a Grid class again, which provides a Java API, which is then forwarded to this JavaScript. So that's the API to talk to the embedded component. So they are not even isolated. Again, if you know what to do and if you follow the documentation, that should be easy to do. When we did it the first time, it took us a bit to figure that out. Okay, so let's have a look at that in the IDE. So now we just double-click an existing Ecore file. And here's our editor. This is really a prototype. It's not perfectly styled, but it should look familiar. So we added all the icons. And we can click any element in that editor. We have a details view. We can even modify things. So for example, we can modify the name. You see we have updates in the tree, and all these basic features are there. Actually, we didn't spend more than a couple of hours on the editor itself because it's provided by the framework. So the main effort there was to get the icons in and do some styling. Actually, we applied styling to the editor to fit into the Che look and feel, so that has a dark background and so on. And besides that, the editor is fully functional, so it can modify all the attributes, but we didn't customize it. And there are some specialities in Ecore, for example, lower and upper bound, which you want to display differently than the default. We didn't spend any effort in this because this has nothing to do with Che then. Yeah, but besides that, I think that shows what we wanted to do. Okay, let's go back to the slides. Now, what I was not telling is, when I introduced the JSON forms editor, I was mentioning that it consumes a JSON, but what we actually have is an Ecore file. So how does that work? How does that relate to each other? What we actually did is we added a custom REST server to the Che server, a JSON Ecore converter. Luckily, there is a framework called, is it EMF to JSON, right? Yeah, which does a conversion between EMF and JSON. So we just needed to fix, I think, one bug, but that worked out pretty well. And this JSON Ecore converter service is then accessing the file service of Che. So it reads in the Ecore file, transforms it to JSON, sends it to the client, and then we can modify it same way back. So again, we just used an existing framework to save a lot of work. Okay, let's come to the last part of the use case, how to generate code. Obviously, we didn't want to re-implement the EMF code generator. So we wanted to find a way to reuse it. There are actually two main ways how to reuse such existing components, such existing tools. First way would be pretty similar to the converter that we wrote. We could implement a service on the server written in Java, which then uses the API of EMF to trigger the code generation. And EMF supports that. If your tool doesn't provide such an API, and if you require OSGI to run it, then it gets more complicated. You have two chances to resolve that. One is you re-implement the framework, or you refactor the framework to provide this API. That's actually the Che team integrated some JDT components, and they actually refactored them in a way so that they provide an API, a plain Java API. There is a second point, or a second way of bringing tools into Che, and we took the second way because it's adding another interesting feature of Che. I was talking about those extensible workspaces before, and they are Docker containers. And we can extend those containers and add any tooling we want. And it's possible to execute the EMF code generation from the command line. So basically, we don't talk to a Java API, but we just deploy a ready-to-use application in our workspace, which contains a small OSGI runtime and the EMF code generator, and then we can just trigger it on the workspace. And thereby, we don't need to change EMF at all. We just need to call this command line. There are three ways how to call those commands. So let's switch back to the IDE. The first and simple way is there is a console down here, and that provides access to your current workspace. So the developer at runtime could execute any kind of code. So for example, if you want to talk to Maven, you can just execute Maven here. Now, potentially the user could just call the EMF command to trigger the code generation. Of course, we don't want that, do not want that, because we want to have it more integrated. If users identify command that they execute more often, it's possible to extend or to save those commands. And if we look up here, there's a list of ready-to-use commands, and you can actually, the user can define their own commands. So we could save it there. But we wanted to provide tooling to the user and really make it integrated, for example, in a menu. So you can also programmatically define those commands and then attach them to an action. And that's what we actually did. So now if we right-click on an Ecore file, we have this generate action. And then if we execute it, you see we actually trigger a command on the workspace, on the Docker container, which now generates the code. That's literally only 1 or 2 lines of code that we did, and we were able to reuse the complete code generator. And now you see the source folder appeared, and we generated the code from the model. Very good example of how it's sometimes very easy to reuse existing functionality. Okay, so let's go back to the slides. Okay, let me wrap that up, and also I would like to summarize the overall experience. So when we got started in March or in April, we were, I would claim, one of the first parties together with Red Hat or SAP which started to really extend Che. So it was just released in March, and in April we already started to extend it, or we tried to extend it. They had a lot of existing documentation, but based on the 3.0 version, but it was not yet converted to the 4.0 version. So in the beginning, there was not a lot of documentation. There was a lot of documentation how to use the tool, but not how to extend it. The good news was two things. First, the team is very, very helpful and very responsive. So we got in contact with them, and they answered all our questions. So if you ever want to extend Che, I recommend you to contact the team. Probably they now hate me for that. The second good news is that the group of early adopter, that was mainly SAP, Red Hat, and us, we contributed documentation. And now there is a resource center about how to extend Che. I think it's over 100 pages long now. It covers all the use cases that I presented today and much more. So if you start to extend Che now, you're I think in a very good position documentation-wise, because all these standard cases are basically covered. Of course, there's a lot more to document, but I would call it a pretty good state now. The other thing was like API-wise or stability-wise. When we joined the project, it was directly after the 4.0 release, and they were really in heavy feature development. That has improved a lot since then. Already in June, the API were very stable, and now I think we are at 4.7, no 4.5. We rather have any changes in the APIs that we use. So I think now is a very good time to start to extend Che, because documentation is there, API has stabilized. You can get in contact with them. In general, I would say the biggest problem that you might have if you start with Che is that it is a complex piece of technology, because it's a combination of Docker, a grid application, a server, the workspaces, and so on. So because it's so powerful and covers really complex use case, it also uses quite a few technologies. And you have to get familiar with those technologies. If you're not familiar with Maven, you have to learn how to use a Maven build. You have to learn how to use dependency injection. You should get some basic knowledge with Docker. So that's quite a ramp up, but it actually pays off. And if you cover those basic hurdles and you get familiar with the framework, it's actually a lot of fun to develop with it. The API is designed nicely. It's very extensible, and it has a cool look at the end, so it's really fun to develop it. If I would have a wish, the biggest thing that to be improved is the build. So it would be very cool to have a shorter build time or be able to just